So in this series of videos, we're going to focus on the robot character that you can use to interact with your props or environments, that pieces that you may have turned into skeletal meshes and are animating. So here on the screen, we have this robot character that hopefully you've seen a few times. I've shown it off in class and how to use it. And now I'm going to create the actual videos that'll show you how to animate with it, create the files with it, and bring them into Unity. So if you check on the Moodle page, he's listed a few weeks ago as this kind of Acme basic rig. I'm probably going to rename him to something like SK Robot Maya Ready, and then like SK Robot, which is just the skeletal mesh. I'm going to show you how to create that, but I'm going to create it because it's a little more involved. And I'm also going to show you how to go through and bake out the animations and what have you. So anyway, I just opened up this Acme basic rig. Again, I'll post it up as something like Maya Ready. But when you first open it, first to be aware of is the geometry, and we have these curbs, these nerve curbs, which you should be familiar with when we modeled using the revolve techniques. Let me just quickly go over the layers over here. So in the display layers, you see we have this geo layer here. And if I turn it on and off, you see it's the actual robot geometry, and you see we have, that's V for visibility, and you see we have this R here. So I don't think I've covered this in previous videos, but if I turn it off, meaning this is just like kind of a normal display layer, I can click on everything that was in that layer. I can click on it. I can click on anything else that was outside that layer. Now if you click on it again, I get this T. That's T for template. And what you'll get is this kind of grayed out wireframe. That's really good for if you're using it as a reference to model on or something. So you can't click on it, and it's a wireframe. Now if I click on it again, we get R, and R is for reference. Again, we can't click on the geometry that's on the layer. I can click on these control curves, but they're not part of the layer. You see if I turn the layer on and off, the control curves stay. So you see I can't click on it, but everything's in shaded mode. So by default, this file will have this robot character, his geometry will be referenced on a layer like this, meaning you can't click on the geo. And the reason we do this is it's much easier to click on these curves, and it's these curves that you're going to animate on. So it's a nice way to not have to click on, accidentally, see if I turned off the R, and say if I wanted to click on the curves, sometimes I might click on it, sometimes I might click on the geometry. It's just another layer of difficulty that doesn't need to be there. So again, T for template, you got a wireframe, R for reference, you can't click on the geo. So let me open up the outliner. I was looking at this, the way that this is grouped, and it's actually a little messy. This can be cleaned up. Basically, this group 6 is, if I open it, it's the geometry for the left fingers. So I can pretty much call this like fingers left, and this over here happens to be fingers right. You see if I open it up, it's just fingers. Oh, is that the left? He named them all left. It doesn't matter. Usually left and right is in relation to the actual character. So if I'm looking at him, I would say that this is left, but actually when you kind of get into position of the character's point of reference, field of view, you see that this is actually his right hand, because I swing the camera around and I'm looking behind him, just like if I was this character, this is the way I would be looking, and this is actually his right hand. So I mean, it's a little strange. Usually you're going to look at a character head on like this, and you might be tempted to say this is left hand, but technically it's his right. And then when we talk about left and right, that can be relative to your position, and we take that in regards to the character's position. So these groups of geometry, actually I can move underneath here. This is like the base group of this whole character, and this group just seems to be a leftover, an empty group of whatever the rigger who's working on this. So I'm just going to delete that. So I'm actually kind of creating the Maya Ready file right now for him. So this top group, instead of this basic rig master, meaning it's the master top of this character rig, I'm actually going to just call it SK Robot, because I'm starting to develop this file to be like the skeletal mesh. So underneath here we have the control group. Basically it just has this one master control right here. I'll get on this in a second. We have this scale group, which has all of the control curves and the eyes selected. Non-scale is the geometry. And then we have these finger groups. So actually these finger groups are part of the geometry. I could just move them in here under non-scale. So what this means is what is being scaled and non-scaled. When you import this robot into your scene, you're going to have to scale him to appropriately fit into the scale of your scene. So what these groups are saying is basically it's basically scaling his control curves, which basically scale up his bones, which scale up his geometry. You don't want to also scale up his geometry because you'll get like a double, not only are the control curves telling the bones to scale up, telling the geometry scale up, but then you're also telling the geometry scale up on top of it. So you get like a double scale up. So basically the non-scale is all of the geometry of this character. Now the eyes are in the scaling group because the eyes actually have a scaling attribute. I'll get to that in a second. And then the master control here. So all you really see right now is the geometry and these control curves. But if I go show and I turn on joints, you see that you'll see the joints underneath the character. And I can grab a joint, and you can see that it's actually, I can't move it. So what's going on is that all these bones, all these joints, which is driving the geometry, are actually controlled, are constrained using these constraints I showed you earlier, the point, orient, parent. These control curves are actually driving the bones, and the bones are driving the geometry. So this is how in an animation studio, it's very traditional to have a setup like this. So the animator will not touch geometry, will not touch the bones. They only touch these control curves. And again, these control curves have a control over the bones, and the bones are controlling the geometry. The geometry is skinned to the bones, and the bones are being controlled by the control curves. And the point of that is that there's so many bones, it's so annoying to have to animate each and every little bone. So I can hide the bones away, and we can just use these control curves, which makes for a much easier time to animate things than actually have to go in and manipulate each bone. You can really see on the extremities here, if I just grab this foot control, you see I'm animating this whole leg, and if I go show joints, let's look at all the bones that are moving. About 1, 2, 3, 4, looks like 5, including the tip of the foot, are animating. So if I didn't have this setup, this rig setup using these control curves, which are controlling the bones, which again are driving the moving around the vertices on the geometry, then I would have to go in and animate each and every bone. And on top of that, see what ease of control I'm getting over the entire leg. It's looking very fluid, organic. It looks like body motion. And to go in and then I have to rotate this bone and move down and rotate this one. It's insane to do that. So that's the other reason why we use these control curves. So I'm going to go Control Z back, put him back in place, and I'm going to unhide his bones. So that's the whole point of using these control curves. You can key on top of them, and all they're doing is driving the bones, right? So I can place a key here, move this thing, place a key, and I could scrub, and the control curve actually has the animation on it. You can see because it's red up here. But he is actually moving these bones, which don't have keys on them. They're actually just moving because they're being constrained using these constrainments by the control curves. When we're ready, when we're done and happy with the animations, we're actually going to bake the animation down onto the bones, and that's how we're going to get this animation into the game engine. But for now, we're within Maya, and this is like the Maya version of this character using these control curves. So let's start from the base up. So when you import the character, and the first thing you're going to want to manipulate is this master control curve. This will be used for placing your character around in scene, and for scaling him to fit your scene. Next up is we have the hips here. You see, it's the real base of the body. It's controlling the legs and the torso all the way up the stomach, the chest, up into the head, and is also controlling the arms just because they're attached to the torso. So you see, as I'm kind of working up the from the major influence points down to the smaller influence points. So I'm going to work on the master control, up the hips, up the spine to the head, show off the legs and the arms. And that's actually how you're going to think about animating. When you're going to bring this guy into your scene, you're going to use this master controller to place him, rotate him. And once you're done with that, you know, you're going to start at the hips, blocking out your animations based on the major motion of the body, and then look up, you know, and move on up to how the rest of his body should be moving. So it's very common practice to look in a mirror or watch reference videos on YouTube on how people are moving, or whatever it is that your specific animation task is, whether it's a walk cycle, someone's running, someone's falling, someone's picking up a baseball bat and swinging it. Always look at that reference material to see how that person's body is moving and the timing of each of the areas of the body that are moving, you know, in regards to other areas of the body to get the animation. So back here we have the main body. This you would work on first. Now this is kind of a finer control on the hips. It's just kind of positioning the legs. And now we're getting one step up. This is kind of like the stomach. Here we have the mid torso. Here's the chest. And again, with these joints, you can see it's only the only attributes that are available to you are to rotate. It doesn't really make sense to translate because these main body parts, they don't move away from each other. Your chest doesn't move away from your stomach. It's kind of rotating on each other. The only ones that have translation is that master controller, your hips, your main part of your body, and I'll get to the feet and the hands in a second. They're like the last things that you can move around using translation. So anyway, we were at the torso. Here we have the neck. And here we have the head. Now the head's a little special because here you see in the channel box that we have some new attributes to play with. So these are custom attributes that the rigger created. And these allow other manipulations. So here you saw we were playing with the rotation of the head, but here we have a new category, eyes. So what's going on here is we have this eyes. It's a grayed out value. You can't use it. It's just kind of like an organizational value to say okay, underneath this eyes, these are sub attributes for the eyes. So we have blink left. And you see as I scrub, I'm middle mouse dragging left and right. And if you look over here, you see the value is changing. It's going between 0 and 10. So the value is clamped. The rigger basically says 0 means that your eye's open. 10 means it's fully blinked. So you can animate the blinking of the eye between 0 and 10. That number happens to be arbitrary. You know, usually stuff is maybe 0 to 100, 0 to 10, -1 to 1. It depends on whatever, trying to make sense of what you're doing. So the blink right, same thing. As I scrub back and forth, I can go between 0 and 10. Again, this is the same stuff. You can key. I can set the blink up, and maybe you see how he's blinking, and maybe the right eye starts to change too. And as we're scrubbing, we can see how the eyes are animating. So I'm just going to shift and right click through my timeline to select everything and delete those keys. Next we have big, meaning it scales up. So these are like to add a little emotion to the character. Adding facial emotions, lip syncing the mouth to voice audio, and using all these advanced face controls is really advanced character animation. And if you watch a movie or a game, you can see how much effort goes into animating the face to make it look really realistic, to give that emotional, acting, to make you really feel like you're involved in the game or the movie. So this is just to add a little expression of surprise. So it's big left and right, goes from 0 to 10. And we have this head switch, meaning you can have two different types of heads, cylinder or round. When I make the SK, you don't really have to select this. I'll make an SK that has a round head, and an SK meaning a skeletal mesh. I'll make a skeletal mesh as a round head and a skeletal mesh as a cylinder head. You can choose which one you want. That value you don't really have to worry about. So that's it up to the head. Now let's look at the feet. As the arms are kind of like the most complex area. So let's move on to like the second most complex. That's the legs. And you see it's a little different is I don't have kind of controls going down the legs like I do with the body. And that's because the body is forward kinematics, meaning the motion works its way upward from the largest areas. So that's what I was saying, when you animate, you look at animating kind of the hips. That's kind of the base of your gravity, your center of mass. That's where your motion of your body is going to start with or sustained with. And then you kind of work your animation out. So all these, they all depend on each other. So I can, start with the base. It's like this next one and rotate him. Next one, rotate him. Next one up to the shoulders and rotate him. And you see they all kind of are working on top of each other. So this guy's influencing everyone. This guy's just influencing those above him. Same with him above, up to the head who has no one up above him. But this head is influenced by all the controls underneath him. So that's kind of forward kinematics, meaning the motion is starting from the base and working its way out to the extremities. And again, that's all rotation. So down at the feet, we have what's known as inverse kinematics. And you can rotate and you can translate. And when you translate, what you're doing is basically, these are inverse kinematics. You're actually positioning the foot, and then it's working its way. Let me show the joints. It's actually working its way back up the joints to figure out which position all these joints should be in to make the foot in that final location. So it's like grabbing the final location, and all the joints are working its way backward up to that kind of originating center of mass and figuring out where they should be. So that's inverse kinematics. And you see the real benefit of this one is I just have one control I'm moving, and it's moving a whole series of joints, a whole chain of joints. I'm moving this whole leg very quickly, considering how many joints are in here. So you can see how easy it would be to do a walk cycle over and over again, where how the foot would get placed down and down, just using this one control. So let me turn the joints off for a second. The other thing to note is there's one attribute on the foot, and that's this toe roll. And you see what it's doing is it's rolling the ball of the foot. So when you step, when you walk, when your foot lands, you're landing at the ball of your foot, and then your foot kind of rolls down on the heel to the toe. So as that happens, you kind of could get this toe roll it's known as like supporting animation. It's just more additional animation effects that really sell the fact that, this character is alive. Let me bring the joints back real quick. I did want to show you that there is a root bone in the center. and it comes up to the hips and up the spines and down the legs, and that hip is kind of at the top of the hierarchy of the whole bone structure. That's why you work your way out from him. And this root here, you're not going to animate on, but you're going to use him to place him originally in your scene. And I'll get to that later on. So now let's kind of, the last part on the legs I wanted to talk about was, let me move this leg out, cock him a little bit. And these green crosses, they're known as nulls, but they're very useful in using them as point vectors. So nulls are just empty transform groups. They're used in the control situation in the riggings a lot of times for these pole vectors. And what pole vectors are is helping to point these middle joints, so knees and elbows. You see, as I move this, the knee is kind of swinging around, and you see kind of the base of the foot is kind of swinging with the knee, and the ball joint at the hips is kind of swinging in relation. So these are great when animating. Usually they go left to right in regards to the character. Up and down don't really, they have much effect, but what the real purpose is like you're swinging your knees out or your elbows out. It's going to be huge. If your animation isn't looking right, don't forget to figure out how these should be placed and get animated along with your character. So you kind of work with the hips out, down to the feet, and figure out how these pole vectors should be positioned so that it looks like it's appropriate weight placement on the body. So now let's go to one of the hardest section, really, and that's the arms, because they have two controls going on here. There's a forward kinematics and an inverse kinematics on these arms. So you see these circles, I can grab them, and I can move the shoulder, grab the next one, move the wrist, the elbow, move in the next one, and move the wrist. And that's forward kinematics. You see how I rotate the shoulder affects where the elbow is going to be, and how I rotate the elbow shows where the wrist is going to be. So you can animate. That's one way to animate. And then there's this star icon looking thing. And you see as I move him, he doesn't have any effect. But if I click on the circle on the wrist here, let me work on your way down. I got the shoulder, you can only rotate. I got the elbow, you can only rotate in the Y, actually. So it's restricted, you can't go any other way because elbows can only really bend in this direction. And then when you get down to the wrist, you can rotate in any way you want. These controls, you got the index finger, the middle finger, the pinky finger, the thumb finger. So see here, you got the index. This is like the base knuckle, the mid, and the tip. So these are like the major joints in the finger knuckles. Then you got a spread, meaning the finger spreading away from the other fingers, and a roll, kind of the finger going side to side. So you could animate like the whole hand basically by grabbing all the knuckles. I'm control clicking to click all the base, mid, and tips. You see I can make his hand into a fist and what have you. Now the big thing to pay attention to is this IK-FK switch. All right, inverse kinematics, forward kinematics switch. Right now it's set at 10, meaning it's fully forward kinematics, which you saw with the circles were rotating the arms. But let me pull this all the way to 0. And if you saw it, I middle mouse dragged it to 0. Now I can grab this kind of star object, and look, I can move the whole arm. And just like the foot, I'm moving at the tip of the arm. I'm moving at the wrist. And the shoulder and elbows are rotating to accommodate where this arm, how this arm should be placed, depending on where you want your wrist. All right, so you can't rotate this joint. You can only translate around, and then, when you're happy where it's at, you can go into a circle here and rotate the hand. So we have inverse and forward kinematics on the arm. Most of the time you're going to use the forward kinematics. Now let me just show you something. If I kind of place this arm here and I switch it back to FK, you see that he actually pops back, because I didn't actually move the circle, he was staying here. But you see now the arm pops back to its forward kinematic spot, which right now is, none of these are rotated, they're staying here. And then if you go in between, you see it's kind of averaging out. So if I maybe rotate these arms up and out that way using forward kinematics, and then I've switched back and forth, you see that there's a big difference, and then you can switch like in between them. So there's a reason to use each of these systems. Inverse kinematics, it's very easy to start creating animations. You don't have to, rotate the shoulder and the wrist to get the shoulder and the elbows to get the hand where you need it to. And then forward kinematics is really good for really finessing your animation. So sometimes you want to use one or the other, or you can key them on and off throughout your timeline. And sometimes you're using forward kinematics, and sometimes you're using inverse kinematics. But most of the time, you turn the switch to 0, and you're going to get some nice, good motion going with just the inverse. Now again, you see the arm is popping, right? And that's because I don't have my pole vector placed for the elbow. So you can see when you get these really extreme positions going, how important it is to know where to place your pole vector. So this just looks wrong. Looks like the arm's broken, so I have to pull the pole vector back, and now he seems to be getting into a good position. So remember these pole vectors too, these green crosses for the elbows and the knees. Now that I showed you kind of the basics of how this robot works, also remember that I kind of changed the grouping here. So remember, now I kind of moved everything into this base group called a SK robot. We got our base control here. We got a lot of our the rest of our controls in the scale group, plus the eyes, because the eyes scale, and non-scale is all this geometry here. So I'm going to close this up, and I'm going to save this as our Maya ready robot, because he's nice. He's cleaned up a bit. I moved the groups in with each other. It's going to make for easy dealing with him within your room's Maya scene, and when you're exporting out his SK animation. So I'm just going to call him like SK robot Maya ready, and this will be up for this week. You'll be able to download it. Now I'm gonna show you how to create the skeletal mesh version of the file, but I'm not going to expect you to create it, because you do have to go through and clean out his guts a little bit. So let me go back and show joints. And I'm going to show you how to go through this, and then I'm just going to give you the file. So hopefully it'll just give you some understanding of what's going on here. So again, these are all bones. You can see how many bones there are in the hands. So you have the geometry, the bones that are joints that the geometry is skinned to. Again, that's just weighting information on how the vertices should get deformed, moved around based on where the bones are moving. And then we have all these control curves and these nulls, which are part of the control system. And all they're doing is the joints are constrained in some way to these control curves so that they inherit animation from them. So when I create the skeletal mesh version of this character for use in the Unity game engine, all I want, just like all our other skeletal meshes that we've been creating, is just the geometry and the bone system. So I'm actually going to go through here and again, we have the master control, we have all the controls plus the bones, and we have the geometry. So what I'd like to do is basically I'm going to hide the joints, and I'm going to hide the polygons, and all we have left is the joint is the control system, and I can delete that. I could go back and show my polygons, show my joints, And now we just have the character, and you see he's the bones are still controlling him. So this is good. And again, we have that root, and this will be used for placing and scaling him. All right. Now there are some other elements here. Let me show all. And you see that there's these IK effectors. Basically, these were part of the IK system that is used to get that control going at the hands and feet using that inverse kinematics. So that should be everything. Got the joints. Here's some more IK stuff. So this is the other head. All he's doing is actually hiding the other head. Delete some of this hidden geometry. Go through the skeleton a little bit. Here you see all the entire skeleton. Here's some effectors. Here's the eyes. They're fine there. They're actually just kind of sitting with the head joint to go around with him. Then we have the finger groups down here. All right, so good. You see, as we move him, he's very stiff, and there's no other IK effectors or anything. So all we have right now is the geometry and the bones that the geometry is skinned to, and that is a skeletal mesh file. So for this one, I wanted to delete. This is, if I show it, that's the round head. So let me undo that. I'm going to delete it for right now because I'm just creating the SK for the cylinder head. So I can do export all, and again, this is the geometry and the bones. This is my actual skeletal mesh. So I'm going to export when this loads up. All right, I'm going to call it SK robot cylinder head. Export that out. So you get these errors sometimes. It just comes with experience what this is saying, and for me, this isn't important. Everything that came out with that export was correct. So I'm going to undo a few times so I get my hidden head back. And display, show. And now I'm just going to create the round head. I have to unreference this so I can click on him, delete him, and now I have the round head. All right, and I'm going to have to scale the eyes out a bit to place them correctly. All right, so now we have a round head, and again, I'm just going to export him out. All right, robot sphere head, export, and it's done. All right, so now I have my SK files created. So I have the robot Maya ready, which is going to be the rig with the control curves on, everything in it they can animate on it. And then we have the sphere head and the cylinder head skeletal mesh of that robot, depending on which head you want to use. So that's the skeletal mesh, and now all you're going to be in charge of doing is creating animation files for the robot. So in the next video, I'm going to jump into my room, import in the robot, have him animate along with the vase or the lamp or something, and export him out, and then create his animation files and put them back into Unity so that it looks like he's, shaking the lamp or grabbing the vase or whatever.